Alright, this is APAB Calculus, and we are doing 2.2, which is the start of the basic differentiation rules. So before we get into actually doing math, we're going to make a ton of note cards. Now, I mean actual note cards. Don't get me wrong, Quizlet is awesome and a great way to memorize things, but there is something to be said for actually making physical note cards that you memorize, and I apologize to whatever trees will die in the process. So, a couple things about your note cards. Number one, you don't have to buy actual note cards. You can just take a piece of, you can take a sheet of paper and fold it into, sixths, right? Fold it down the middle and then fold it in thirds or fold it in eighths and use that and cut it into pieces and make that note cards. It doesn't actually have to be a physical note card. I know in high school I made, my mom had a ton of legal pads, like the big yellow ones, and I just used all of them to make a ridiculous number of note cards for calculus class and quiz bowl, and that's totally fine. But you should have some physical thing that you can quiz yourself on. This is good for a bunch of reasons. Number one, studies have shown that actually writing things down helps you learn it as opposed to staring at it on a Quizlet, right? Looking at it on the screen. Number two, we all already have way too much screen time. I understand the irony of me saying this while teaching you through a screen. And number three, nobody's gonna mug you for your note cards, probably, right? And if they do, they just want to learn. So good on them, I guess. But if you were studying on a phone on Quizlet or something, and it's a really nice phone, maybe somebody's going to take it, right? But in theory, nobody's going to jump you for your note cards. Again, if they do, they probably just want to learn, and you should see if they want to be your study buddy or something. I don't know. Anyway, so you need to learn all of these rules. Now, a couple caveats about this. The ones that I starred with orange are ones that don't actually show up in section 2.2 of the textbook yet. However, they're going to show up soon, and since you're going to have to memorize a whole bunch of these, it's kind of worth just making note cards now. After these 13 differentiation rules, there's only a handful more that you're going to need to learn, like under 10 total, so under 10 more. So really we're looking at probably in the neighborhood of 20 to 25 total differentiation rules that you need to get through Calc 1. But you do need to know them, and they need to be quick recall information, right? It's sort of like how when you were a little kid, if I asked you for 6 times 7 and it took you a little bit, it was fine. But now if you can't do 6 times 7, it's going to be an issue because it comes up in other math, right? Recently, a friend of mine went back to school to do computer science stuff and has to take Calc 2. And the other day he said to me, oh my gosh, it's just killing me that you have to memorize all of these rules. Like, if you don't know the rules, you can't even do the problem. So, and that's really the truth of it, is that you have to know this. So, those are my little caveats about things. So, let's talk notation for a sec. This dx notation means differentiate. It's a command that means differentiate, right? Sort of like how an absolute value is a math command that tells you to make whatever the output is non-negative, right? Like the absolute value of -5 becomes a +5. ddx in front of an expression means take the derivative of or differentiate that thing. So here we're using the letter C to stand for constant, right? So it's just a number, right? So when you make your note cards, what you want to do, and I actually made note cards for all of these just to show you what I want you to do. I apologize in advance also that my note cards are violently colorful because I got them for something else, and so they are like neon colors, right? And I'll explain why I have different colors of cards in a minute. I picked the yellow because it seemed to be the least visually assaulting of them. Sorry, that's upside down to you, my bad. Okay, so on the one side, you're going to put the front thing, so ddxc, which means take the derivative of a constant, right? And on the back, you're going to put what that derivative would be, right, which would be 0. So d over dx, which we usually say is ddx, c, right, which would be take the derivative of a constant, you get 0, right? So you're going to make a note card for each one of these, right? I don't need to stay on this too long because you can pause me and go back and make a note card if you need to. So the next one is called the power rule. So if you have an x to a power, right, so x to some power n, right, the derivative of x to the n is n x to the n minus 1, meaning you drop the power that was up here, you put that down in front as the new coefficient, and then you lower the power by 1. Okay, that's called the power rule, and I wrote that underneath. That's the power rule, right? Remember, c was some constant. If I have a constant in front of a function, so if I'm asked to derive c times some function f of x, I can just pull the c out and only derive the f of x, right? So again, the derivative of c times f of x is just c times f prime of x, which would be the derivative. Same thing is true of sums and differences, right? If I want to differentiate a sum or a difference, so f of x plus or minus g of x, I just differentiate the pieces. F prime of x, which would be the derivative of f, plus or minus g prime of x, which is the derivative of g. Notice that there are no rules listed here yet for products and quotients because you do not know how to derive or to differentiate rather a product or a quotient yet. You don't know. So just trust me, we'll get there. In fact, that's chapter or section 2.3 and 2.4. We'll talk about products and quotients and chains. Okay, then we hit the trig derivatives, right? So this whole column is the trig derivatives. Now, I also put a note here about color. So you'll notice that I'm going to have some different colored cards in a second, and there's a reason I have different colored cards. So when you're learning, you probably know things about your style of learning. Everybody knows some stuff that they're good at. I know, for instance, that one thing that helps me is to make up stupid rhymes and stupid sort of sayings in my head to help me remember things, right? So when I was remembering, or when I'm working to remember like lots of books and things for Quiz Bowl, I'll frequently make stupid puns based on titles to try and remember them and who wrote them or whatever. So I also know that singing things helps me. So sometimes I like sing a song in my head or I say a phrase in my head. And on some level, I'm very much an auditory learner. Some of us are very much visual learners. One of the things that you can do to kind of augment your learning and give you more likelihood of remembering is that with these trig derivatives, most of the trig derivatives are positive. So the derivative of sine is a positive cosine. The derivative of tangent is a positive secant squared. And the derivative of secant is a positive secant times tangent. But what I want you to look at is the three that I didn't highlight just now. They're the same basic pattern, right? Like sine and cosine are related, except that they're the negative. So the derivative of sine was a positive cosine, but the derivative of cosine is a negative sine. Just like tangent was a secant squared, cotangent is a cosecant squared, right? But it has a minus. And so just like secant was secant times tangent, cosecant is cosecant times cotangent, but has a minus. So when I do my trig differentiation cards, I tend to I do use different color cards here because I happen to have these violently neon cards that were in a cabinet in our desk. But on regular note cards or on paper, what I would do is I would write the positive ones just in whatever normal color of ink that you would use, and then I usually write the negative ones in red. So that if I'm blanking on a test or if I'm panicking about how to remember this, I can say, wait a second, oh my gosh, that was a pink card. Ooh, that means that it's negative. Or, oh, that card was written in red, I'm pretty sure there's a minus. Because one of the things that the AP does to trick you is they'll give you an answer that is almost entirely correct on a multiple choice problem, but with a stupid minus that's either missing or shouldn't be there or whatever. So again, adding a visual cue is just one other way to remember this. You don't have to do it. You do need to memorize all of these rules. So again, the front side, right, and then the back side, right? So that's why the different colors of cards. Don't mind me with my ridiculous number of things. Okay, and then these last three are ones that you're not going to see for a little bit in the book, but I'm going to introduce now because there's no point in not telling you most of these on the front end so that you can start using them, okay, and start practicing with them and learning them. The derivative of e to the x is the easiest of all the derivatives. It's e to the x, right? The derivative of a to the x, which is any other number, right? Any other number that's not e, right? So 5 to the x, 2 to the x, whatever, is the natural log of that number times that number to the x. And lastly, the derivative of the natural log of x is a 1 over x, okay? So if you didn't already pause me and make these note cards, you should pause me and make these note cards now. And then we're just going to practice differentiating. So here's the reason you want to use these rules. You're not going to have to do that horrible limit definition of a derivative anymore, right? At this point, you're going to be able to differentiate much more quickly, and you're going to be able to take stuff that we did in the last video that took us forever and find the derivative almost instantly, right? So that's kind of the idea. So I'm going to stop this video now, and then I'll erase all these, and I'll set us up to do some examples with some basic differentiation.